So first of all, let me give you an introduction and background. Our project analyzes consumer price index data from Pakistani cities using discrete mathematics. We focused on 2 years, 2023 and 2024, across seven product categories including food staples, meat and dairy, utility and transport, and others. We built networks of cities where each city is a node and an edge represents similarity of price patterns for that category and year. To measure similarity, we use cosine similarity, which focuses on the pattern of price movements rather than absolute price. Secondly, data preprocessing. For the PBS dataset, we dropped all rows with missing values to avoid bias, grouped products into seven category sets, split the clean data set into two equal halves, simulating CPI data for 2023 and 2024, applied z-score normalization using standard scalar so all cities are compared on equal scales. This ensures similarity results show true pattern relationships unaffected by price magnitude. Cosine similarity and threshold networks. For each category and year, we computed cosine similarity through the given formula. We constructed networks using three thresholds: zero point 0.6 for dense networks where almost all cities were connected, zero point 0.7 for moderately dense where best balance and visible hubs was seen, zero point 0.8 for sparse, only strong relationships. Graph and heat map interpretation. We generalize visualization through two methods: heat maps and network graphs. In heat maps, yellow shows high similarity whereas purple shows low similarity. Food staple heat maps were generally brighter, i.e., showing stronger national integration, and utility heat maps showed mixed colors, showing more regional variability. In network graphs, node colors showed entropy weight influence scores, edge thickness showed similarity strength, and 0. T is equal to zero point 0.7 graph clearly showed hubs and clusters. This visually confirmed major economic clusters among cities. Temporal relation and Hess diagram. We defined a temporal relation of the given formula. We verified it as reflective, anti-symmetric, and transitive, so it forms a partial order. Hash diagram's mini description shows that if 2023 edges belong to 2024 edges, one upward arrow or market integration is shown. If neither includes the other, disconnected nodes are seen, i.e., indicating market restructuring. Food staples usually showed integration in the 2 years, and utility and miscellaneous often showed incomparable networks, signaling volatility. Now, for the central measurements, I will hand over to Yaya.
Assalamu alaikum. So I'll be starting from the centrality measurements. So for every category year threshold networks, we computed the degree centrality, which is the number of direct price similarities, and secondly we did the computed the closeness, the speed of influence spread, and the betweenness, in which the cities acting as bridges between clusters, and the eigenvectors importance based on their influential labors. And at threshold 0.7, the structure was most meaningful with clear hubs and connectors. Weighted centrality aggregations in each city receives a score, which was calculated through the given formula. And we use three weighting strategies, which is equal weighting, and which we calculated 0.25. This treats all measures equally and favors cities that score consistently across metrics. And entropy-based weighting, which is higher entropy is equals to more variability, and which is equals to more informative. For example, food staples, where the threshold is 0.7, and the degree we calculated was 0.24, and the closeness we calculated was around 0.28, and the betweenness we just calculated was 0.31, where the largest variance, which indicates the largest variance and which is proportional to highest weight. And the eigenvector we calculated was 0.17. So this emphasizes basically the cities with unique structural roles, especially bridges. And now moving on to the correlation based weighting. So the metrics that correlate strongly get less weight. Degree and eigenvectors often show high correlation, down-weighted, and the betweenness captures non-redundant information, which is up-weighted, and mini description of ranking shifts. So under equal weighting, big metropolitan hubs dominate. And under entropy and correlation weighting, so the regional connector city rise because of high betweenness. An example from the report is that the city, when we look at the city A drops slightly when betweenness is emphasized, and the city B rises because it links separate market clusters. So the main project insights were the network structures, staples, nationally integrated, and the utilities, uh, strong regional clusters, miscellaneous unstable structures between years, and temporal findings. Some category shows 2023 to 2024, which is the increasing integrations, and others are incomparable restructuring and shifting market relationships. So the threshold effect, which is the optimal, what we found is that optimal threshold was 0.7, which captures meaningful structures and a wide noise of 0 0.6 and sparsity of 0 0.8. So we applied what basically in conclusion, I would just conclude that we just applied discrete structures relations, the partial orders, and the graph theory on real CPI data, which was provided to us, and we validated the temporal partial order and built centralized influence scores. We used three weighting techniques and visualized network evolutions using a heat maps, the similarity matrices, and the network graphs, and the hash diagrams. So our work shows clear economic clusters in Pakistan, shifting market structures and across all years, across the given years, and how mathematical weighting changes which cities appears influential. So that's all from our side, and thank you very much.